even though the lungs are mostly important for pH balancing. Here's an overview of the renal compensation for acidosis. The kidneys can still do a lot. So the basic equation is still remaining the same. CO2 plus water with the help of carbonic anhydrase, but even without the help of this enzyme, it will combine to form carbonic acid, which then dissociates into hydrogen ions and bicarbonate ions. The bicarbonate ions, they can be moved into the interstitial fluids, they can be moved into the blood. The hydrogen ions, your kidneys can decide to excrete the excess hydrogen ions and just secrete them out, and you get rid of them. For the most part, your urine will have an acidic pH, so especially in the morning, usually the pH is somewhere around 5 or 6. Definitely acidic, unless you are strictly vegetarian. That's when you might have a pH that is above 7. Renal compensation for your acid-base balance also includes transporters, and here are some listed: the apical sodium hydrogen exchanger NHE, on a basolateral sodium bicarbonate symport. Then we have a hydrogen ATPase, a hydrogen potassium ATPase, and then sodium ammonium antiport. So these are some of the examples. And here's what the proximal tubule reabsorption of filtered bicarbonate looks like. We're starting out here with the sodium hydrogen exchanger that secretes hydrogen ions. And we'll jump over here to 2. The hydrogen in the filtrate is combines with the filtered bicarbonate to form CO2 based on this equation right here. Then CO2 diffuses into the cell and by forming carbonic acid, so CO2 plus water forms carbonic acid, which dissociates into hydrogen ions and bicarbonate ions. The hydrogen ions then will move over here, and they're being secreted again, versus the bicarbonate ions, they're being put into the blood. In the end, you may secrete some ammonium, which you can smell actually in your urine, while the hydrogen ions, they will combine with ammonia to ammonium ions and get excreted. That will be right here. Also, any kind of glutamine that may have formed is metabolized to ammonium ions and bicarbonate ions. Now, in case of acidosis, you have type A intercalated cells in the collecting ducts in the kidneys, and they function when you have an acidosis situation by excreting extra hydrogen ions, and then the bicarbonate and potassium are reabsorbed in exchange. So basically, we're still following the same formula here. Water plus CO2 with the help of carbonic anhydrase makes carbonic acid, which dissociates into hydrogen ions and bicarbonate ions. The hydrogen ions, if they are in excess, they will be pumped into the lumen of the tubules and will be excreted in the urine, and so that will affect, of course, your your urine pH, but it's not usually a major concern. And the bicarbonate acts as a buffer for any other excess hydrogen ions. In case of alkalosis, the type B intercalated discs, they will still follow the same pattern of water plus CO2 forming carbonic acid, but in this case, of course, you don't want to excrete any hydrogen ions because you're already short on them because you're in alkalosis. And so now you want to make sure that the hydrogen ions are getting returned to the blood, where they then balance the pH to where it should be. Here's your summary of your acid-base disturbances. Your blood pH is supposed to be right around 7.4 with not much margin of error. You have a little wiggle room, but it's only 7.38 here to 7.42. It's not much at all. Anytime you're in danger even of falling outside of that green range. So if you're falling below 7.38, then you will be having an acidosis. If you're above 7.42, you end up with an alkalosis, and then you have renal and respiratory compensation that will move you closer back to homeostatic values right around 7.4. Keep in mind that the respiratory system is more powerful than the renal system, maybe surprisingly, but respiratory is about 3/4 of the power to compensate for any kind of acid-base disturbances, and renal takes about the remaining 25%. Here is your summary of any kind of disturbances in the pH balance. Anytime you have too many hydrogen ions and you are dangerously acidic, that's called an acidosis. And you may have a respiratory or a metabolic acidosis. Respiratory acidosis would be that you're keeping too much CO2 in, and so therefore you have increased levels of CO2, and CO2 acts as an acid, and therefore you have a respiratory acidosis. The way to compensate for that would be to breathe out more CO2, so that means you need to breathe more often and maybe more deeply. Metabolic acidosis would be that for some reason through the steps in your metabolism, you produce too many hydrogen ions. Either way, the pH is down, so you're moving more acidic, and you could compensate again for that with your respiratory system. So let's say you have a ketoacidosis, that would be a metabolic type of acidosis. Patients like that, they arrive in the hospital, they're probably in a diabetic kind of emergency. They're arriving at the hospital, they're hyperventilating already because their body's trying to compensate for the extra hydrogen ions. So metabolic acidosis, an example for that would be a ketoacidosis. Just as a side note, you might wonder how about the keto diets. Well, if you are on a keto diet, you are trying to encourage your muscle cells to metabolize mostly fatty acids, and it does produce some keto bodies, but it should not lead to anything near a ketoacidosis. Now, when you're diabetic, you cannot take any kind of carbohydrates into your muscle cells. That means you're forcing your muscle cells to exclusively metabolize fatty acids. In that case, it is so extreme that you may end up with a ketoacidosis. And again, for any kind of acidosis, you can compensate by hyperventilating and using your kidneys of excreting extra hydrogen ions. Alkalosis can also be either caused respiratory or metabolically. A respiratory alkalosis would be that you're hyperventilating, and so you have decreased plasma concentration of CO2. That means you breathe out too much acid, and well, I guess the way to compensate would be to stop breathing so much. You may also end up with a metabolic alkalosis, which is rare, but still you would have an increased plasma pH, and I guess you could compensate for that by breathing less and keeping your CO2 in. And again, the CO2 acts like an acid.